Okay, so let's get into it. Chapter
Professor,
one.
one question. I apologize.
Yes,
Are we going to meet up, like, physically, or this is completely online?
this is completely this way.
Okay.
Mhm. We're going to talk about client server and peer-to-peer models. We're going to briefly talk about applications and protocols and some hardware devices for networking, right? Layers of OSI model, and then best practices and troubleshooting. I'll leave for you to go over. It's rather quick. So these are terms. What's a topology? Physical, logical. What's a network operating system? So topology is that diagram that you see how things are connected together. Like this. You have a computer that's connected to a server, another computer, another, right? So there's a physical topology. Um, how does the hardware play within that network? And then there's a logical topology, which could be different, right? And has to do with software. And then we have network operating systems. Now, can anyone tell me what the difference between an operating system or just OS and a network operating system is? Or anything at all. It doesn't have to be a definition, right?
Would it be that operating systems are programs run by the computers at the points that connect to the server, and then the network operating system is the program installed in the server that controls and configures the entire network?
Right. So, as we will see, thank you. Yes. As we will see, this is a client server model, like it says here, not in a peer to peer. So, it's just a more specific type of operating system used to manage networks, like Windows Server, whatever version, 2016, 2019, or Ubuntu Server, or a Linux version that's specifically for that, right? Um, they don't necessarily have a nice um, this, like a screen. It could be just text based, like a DOS or such. Yeah, command prompt terminal, if you're familiar with those. They don't have all the bells and whistles that you need as a user, because this is specialized software, and you're using a machine that's specific for the server to control several aspects of a network, right? All right. So let's talk about peer-to-peer. Peer meaning fellow person, computer, right? That's a peer. You have a network where you connect computer to computer, but there is no server. It's like me connecting to one of your computers, like, I don't know, the ones that you're using now, most likely, and having a direct connection to it, or via, like a BitTorrent, for example. That's a peer-to-peer connection where you connect through a particular application and then connect to another
Is
one.
that a physical connection or it could be a remote connection?
Either, yeah, it doesn't
Yeah,
matter.
that will still both could be considered P2P.
Right.
There's
So you
matters
can
of,
have two computers connected via a cable, or
right.
you can have my computer connected to yours via the internet. But
Okay.
there's no, I mean, there is a physical aspect to it, because the internet really is it's a big network or set of
Mhm.
networks, but we're not physically close, right? Not necessarily. So important things to know here: computers are called either hosts or nodes, and they are a logical group. You may share resources or you may not. like let's say Ruben and I are connected, our computers are connected, and I have a printer connected to my computer, and Ruben wants to use that printer. He could if I give him access, or he won't if I don't, right? So every computer has a Windows local account. That means that I cannot log in to my account via Ruben's computer, for example, right? So if you go to the college and you say sit in the first row of the class and you log in with your email and password on the computer in the lab, and then the next week you don't find a spot in the front, so you sit in the back, you can still log in with your email and password because that's another model. The computer is not local. Your access is not local. It's all within the network in the client server kind. So you only have access to your computer. If I try my username and password on another one, unless I'm extremely lucky, it won't work. So you have, for example, the diagram here where you have a Windows 10 computer connected in some way or another, cable or not, to an Ubuntu desktop, to a Mac OS, which has a scanner connected to it. And, there's a network printer somewhere in there. This could be your home office. You have 3 computers. You have a network printer. Yes, just in case.
Oh, sorry. Jeez.
So everything you say is in there. But this is for you anyway. I'll put the link. So as you can see, they're connected directly to each other, right? The advantages of it, it's very simple to configure. It's not expensive because you're not getting a computer to manage all the resources, which tends to be a lot more expensive than a regular computer. And the problem is it's not scalable. So when you want to make it larger, bigger network, it becomes more difficult. And it's not necessarily secure. And it's not practical. So good for mom and pop shop, your home office, I don't know, a startup business, that kind of thing. But whenever you have a building, with several computers, you might think that there's another way, which will come now. Now we see the client server network model. And we see the network operating system phrase once again. Everything is kept in a centralized place, right? You can go into any computer. That's what this is basically. Any computer in that network, use your credentials, right? Your login and password, and connect to the resources there because you are not tied to a specific computer. You have something called the Active Directory, which is a database that holds all these usernames and passwords and such that allow you to just input the username and password on any computer. It's going to go to the server, check, do you have access to this computer, to these resources? Yes. Okay, go back in. You're in. That's what this part is. And this process of checking and coming back is managed by this ADDS. Good so far? More terms, client. You do not share resources with each other. I think there's a picture there coming. And you access resources by way of a server. So instead of connecting these computers or devices directly to each other, they all connect to a server. And that server decides, yes, let's use the resources of all these, or let's give you access to these other things. Like if this Windows 10 computer wants to use a network printer, it has to go through the server first, right? If I want to use this local printer, if it's configured, I could technically go from here to here to here, but you know, why would I do that if I have a network printer here? I don't know. This is what the network operating system does, and these are the examples that you would see. I think there's a, I think 2019 is the last one that came up for this one. Very, I guess, cost money, doesn't cost money, and it costs money again. Typically, a server requires more memory, more storage. It
The
has.
Red Hat, that was expensive? Sorry
I'm
to
sorry?
interrupt. The Red Hat,
No,
when it-
no. There's Linux operating systems that you pay for, and there's others that you don't. So it depends, but those are just examples of it.
Thank you.
So in this model, the client server model, the advantages of it are you keep all the credentials in one place instead of every computer having its own. So I can go into my home office, or I can go into Jonas's office, and I could still log in, and you know, the login will be checked into this central database for me to use. All the resources are controlled centrally, and you can diagnose, monitor, and correct any problems from that central location. And it's easier to scale. Definitely easier to scale. Let's see. Am I missing something from here? Not 13. No. You can read the definitions of this. I'm not too worried about that. Important for you to know, protocols are rules, the way to communicate between devices in the network. So you'll see the protocol word at the end of many of these acronyms. TCP, maybe you've seen TCP/IP, or just TCP, or just IP, you know. So if you've seen IP address, that's what this means, Internet Protocol address, you know. Usually, I guess this is getting into the model itself. This will be clearer later. Whenever you go on a web browser on your computer, you type, for example, cengage.com/index.html, which is the main page, for example. This will send a signal through the internet, which is a bunch of networks. It will reach a web server where the website is hosted. You know, the cengage.com is hosted. And this here will say, oh, they're looking for index.html. And this page is sent back to show. This happens in, you know, a very short time. But basically what happens on every single web page that you do ask for is you go through the network, reach the server that's hosting that particular site. The site says, okay, they're looking for this, send that information back. There are several, actually, I made a list of this. Several of these, and you can find them on page 9, 10, 11, partly 12 of your textbook, of popular web service, email service, FTP services, Telnet, and all that stuff that you have to read. So typical of this is the HTTP. I'm sure you've seen that, or HTTPS at some point. Typically in an e-commerce site, you see HTTPS because there's some sort of encryption in there, trying to protect your data, right? Email services, you've seen probably SMTP, or at some point, if you've had a cell phone long enough, with the capability, you've probably seen this POP3 or IMAP4 somewhere in there. Like, how do I put my email on my phone? You used to have to figure these things out or look them up. FTP, if you're into sending not emails, sending data from
Websites.
the net.
Websites.
I'm sorry?
Yeah, ATP is to like transfer files to a website like HTML, CSS, JavaScript.
Right, to go back or forth, right? Either way, like if you're a web developer, you would do that. You would use an FTP to connect to the network, to the web server for your website, Yes. I don't know, and so forth. You can read about these Telnet, remote desktop protocol, remote desktop services. These are all in there, and there's long paragraphs to explain them. It's not super important at this point, but if you want to know more about these, they're there, right? Yeah. This is an example of sending email. You use this protocol to send the email, go to the server for, let's say, Gmail. This goes to the server, let's say Yahoo, and then that one, by using these protocols, get to the one intended recipient. Remote desktop, yeah. All right. You probably heard about LANs, or local area networks. Typically, that's a generic name, I would say, for interconnected computers in a relatively small area. So an office or a building has a LAN, right? Then you may have heard of switches. You may have heard of routers. We'll get to that. Can anyone tell me where you would find this? And excuse me, what's the purpose? Without using these words, I guess.
Where you'd switch you'd find in a network room, no?
That is correct. You could have a switch in your home as well,
Yeah.
right? It could be a
Yeah.
small thing, but we'll see a picture. Actually, it's here. These are switches as well. They're used to just get information and route it, take it, switch it, it says, move it around to another port. You would typically see them as you said, you would see them in a room, like in a network room or a server room or closet, they call them. You'll see them there, so that then everything goes in there, or from there it goes to the different rooms in a building, for example. Topology again. You see topology word. There's star, which will be the next slide. And another phrase, NIC, or network interface card, is what we use to connect to a network. So if you've if you've seen, let me pause this for a second. If you've seen one of these, right, that has this Ethernet here, or the wireless one, with the antennas, this would be NIC. Um, in any case, wherever you see, for example, this place where you connect an Ethernet cable, you are basically saying you have a way to connect to a network, right? It could be wireless, it could be an expansion card, it could be already in it, in your motherboard. There's different ways, but sometimes, let's say your computer, that particular part breaks, you can connect an USB one and have wireless service or wired service to it. Yeah, you would have.
Professor, would you say that NICs?
I'm sorry.
Oh, sorry to interrupt. I was gonna say, would you say that NICs are kind of outdated, or are they still just not like as used?
The thing is, if it's already in the device or not, we still need them. Without that, there's no way to communicate in the network. What do you mean by outdated? Like the particulars? Like,
Well, I mean just the separate card itself. Yeah, the separate expansion, because I know most of the time now they come already embedded in a motherboard.
right, they come in, and you might have wireless, Wi-Fi in there. You might have the cable for it. But they are not outdated, because the moment your motherboard could fail, right? Just like a car sometimes breaks down and you have to change a piece. The motherboard is really hard to change those little pieces, like the adapter, the network adapter. So you would just add an expansion card to eliminate the problem, and then configure that new expansion card and get rid of the other one, disable it. So you will see them anyway. And they could be USBs that you connect outside. If you have a really old laptop, you would see that it used to be cards that you inserted in them. I saw one of those on the campus. Someone gave me a laptop to like disassemble for a class, and it was funny that it still had that. I don't know where they got it from. Yeah, but yeah, generally every computer now, especially if it's a laptop, for example, has a NIC, be it already embedded into the motherboard or with an expansion card. It doesn't matter. I think because the internet is so prevalent, it really is hard to find one without. It would have to be um, really old, most likely. All right, let's go back to the screen. So yeah, more terms. You can have.
Okay, thank you, Professor.
Yes, sir. You have, I think I put them here, lectures. No, additional resources. Whenever you go here, you'll see, for example, chapter 1. You'll see all these things to help you. You will see figures here for you to see. And there's this acronym list. There's 20 pages worth of this that you are to remember. And you can print this out or not to check to see if you know them. What are all these things? Well, I'm not a fan of remembering acronyms, but sadly, you have to know some of them, not all of them, when you get to the exam. And there are a lot. This is just like, come on. You don't need to do an acronym for keyboard, video, mouse. But yeah, they're there. So I put under labs, you'll see additional resources. You'll see the acronym list and all these things. Take a look at these links in order to help yourself with the learning. They're part of they're in the book, or sometimes they're not. And IP addressing, for example, takes you to Microsoft Docs, and they have, this is basically a book there for you to look at different things here. TCP/IP, you can learn a lot from these. here. Anyway, they're here. You will see them appear as we go. You will see them. All chapters are going to appear here. So for next week, you'll see chapter 4 here and so forth. All right. So this is called a star topology because it looks kind of like a star, right? All the computers are connected. Instead of like a server, it connects to a switch, right? It has that similar pattern. The switch is that the one that controls all the. So if I want to connect from this Ubuntu desktop to this Windows Server 2016, well, a cable takes me to the switch. The switch then says, oh, okay, you need to go to that IP. Okay, well, I will take you here. These are the industrial and commercial, or consumer rather, grade ones. You might have seen these. I don't know what I did with mine, but it's small. I had one that had 4 ports. This one has 8, for example. So if you have, we call them routers, but they're router modems really, right? If you have internet at home and you only have one device that comes from the street, a cable connects to that one device, and that one device gives you Wi-Fi, or you can connect to the back of it. You could technically connect one of these to it to increase the number of ports.
Also, one question, if you don't mind.
Yes.
The switch is smart. Is able to get the MAC addresses, not the IP addresses, right? That's for the network. No, that's for the router. So the switch receives MAC addresses from different computers and distributes it to wherever the MAC address goes to. Or how's the? There was a difference between a hub and a switch, and they say that the switch was it was intelligent, was able to send the signal.
Like Jose says, it depends on the technology, but this one here most likely won't. It would be as if you did a cable, something connecting to it, and then continuation of it, like a bridge of sorts. There are some, depending on what layer, and we'll get to that, what layer they work in, that will do more or less functions. But you will need switches in order to extend. For once we get to the cable part, so there are limits to data transmissions within the pieces of hardware that you have, like specifically the cables that connect one computer to, let's say, the server room. And you cannot go beyond those. So if you have a really long building, let's say it's 3 blocks long, you might need to have every, I don't know, 80 meters or so, depending on, how long, you would have to have one of these in order to refresh like the signal. Otherwise the signal becomes attenuated. We'll get to that. We'll get to the specifics of what these do and the differences, because yes, there's hubs, there's switches, there's routers, and they perform differently depending on what type they are and where they are in the network.
Thank
you. Here's again the Ethernet adapter. They should have one of these, which is called, anyone? Well, it's right there, yeah. It's small, but yeah, MAC address, yes. So every MAC address is like saying your social security number, right? It's unique to you. No one else should have it. That particular piece of hardware has one, it's like a serial number, right? You only have that MAC address for that piece. And if there's another one exactly alike from the same manufacturer, the address will be different. And it's a way to identify, that's how the FBI knows where you're at when you're posting on Facebook, right? Because your IP and your MAC, and they say, no, it was this computer, it wasn't that one. It's within here, So each one is a serial number, but I guess in human terms, we don't have serial numbers. We have social security numbers. Um, here's where the several switches part go through. Oh. Again, for the cabling, we'll do more in depth for this, but you have a backbone. So think about your spinal cord, right? Your spinal cord is your backbone, right? And through all these little links that you have in there, you have lots of nerves going through. So you'll have, let's say, a building that has several server rooms, let's say one per floor. And from there, it goes to office A, office B, office C. Each office has 5 computers. Okay, well, there's a cable going from the server room to each one of those computers. The backbone will be what connects each one of those server rooms together to provide network services to all the building, right? Within that one, you will have switches and switches and switches. I'll see if I can find. Let's see.
Yes, sir. Doesn't the router is the one that connects all the multiple switches?
To what? This is beautiful. Okay. To what, Ruben?
Is what I'm saying. A switch connects multiple devices. And then a router is the one that connects the multiple switches. Is that correct?
Not necessarily. You could have a switch to a switch. Like you could have one of these that connects to the other one here and, creates more. The last place I worked did not have them like this.
That's nice.
It wasn't like this at all. Oh my God. It looked more like this mess.
Oh my God.
That was horrible. Anyway, we'll get to that, Ruben. But yeah, some people know what they're doing and they're very organized. Others are not. Anyway, the backbone it says may use different cabling. For example, you could use fiber instead of Ethernet to have higher speeds and then distribute those through the network. You can see here, Ruben, 3 switches could be daisy chain means connected one to the other, like a train, kind of. This is the example of star bus topology. You have several computers connected to a switch connected to another switch. This switch in turn is connected to other computers, and then this one connected to, and so forth. And then eventually, one of these might connect to a router and then connect to the internet. Yeah, you could get that. All right, then comes the router. So we talked about switches, now a router. The router is the policeman in the intersection, or police officer rather, in the intersection, managing the traffic between several networks, 2 or more, right? So if you have a computer at home that wants to connect to the internet, through the internet to another one, you will connect through a router device, right? And the router will say, okay, this is the way you need to go, and so forth. A switch generally, obviously, would say, well, from here to here, and will not go outside of that. A router is the one that connects from, we'll see a picture. Let me see if it's here. Yeah, we'll get to that. A router will connect the internet to your home network, or your home network to the internet, or your home network through the internet, right, to another router in another network, like another home network, or so forth. So we'll see here that says combo devices. We'll get to that. this is the important part that you have to take into consideration. Again, this is very general. There are exceptions to some of the switches. Some switches are do more than this, okay? But generally, a simple switch would just do this. You do connections within your own local network, and a router will be the one that says, okay, you can go out, or no, you don't have permission to go out to one or more other networks. So at home, I mean, if I assume, which you have internet at home or wherever you're at now, do you know what kind of device you use to connect to the internet?
Yes.
So can you tell me what it is?
I use a combo modem, or combo device, I guess. Both a router and a switch.
Okay. So it's just the one device, right? Okay.
That's correct.
And let me look for another one. So images. You might have something. Actually, no, this is a 2. Oof. They're bad.
Oh, that's interesting. How you were just searching, you were Googling while you were on, while you're sharing your screen, you had like 2 screens going. I mean,
Yeah.
Oh,
So this here is a modem or router or a combo device that provides you with both access to the internet via whatever ISP, AT&T, Comcast, I don't know, whatever it is that gives you the service, and then within this single device, you gain access to Wi-Fi or to connect something in the back. I'm trying to look for a good picture for it, but no. What I use at home is more like this one here. Right, you have this. This here is a cable that Comcast gives me. It connects to here, a coaxial cable. Then there's a power cable, of course, for this particular device. And this here is where, if I had the single device, I could connect my computer via a cable and gain access to the net. This is the modem, right? If I want more devices to go and connect, I would have to connect this to a special port here in the back of this router. It has, the wireless signals here. And I could also connect wired, in a wired way, up to 4 devices behind here, right? So let's say I want to use a network printer and I don't want to mess around with the wireless properties of it, and I just want to connect it with a wire, an Ethernet cable. I can connect it here. And this also, of course, has power. So I use this. And can someone tell me why I would use this instead of a combo device? Like, what's the point?
Isn't it for like better security? And they're usually just better devices.
Right. So I'm spending more money, most likely, because I think my router costs like $600. That was a moment of weakness, and this here cost me, I think, like $100. So why on earth would I spend $700 on hardware when I could just either rent it or pay $100, $120 on a combo device? It generally has to do with, like you said, security and also speed, right? So
And longer range as well.
yes. Well, yeah. my router can go to a 3,000 square feet home, no problem. Assuming there's no lead walls or anything, you know. But yeah, area as well. So I do that because I was just like, okay, if I'm gonna spend money on something, I'll just go to the next generation. And you know, as devices come out, I don't have to buy a new one. But yeah, I went from, let's say, having 50 for internet speed to 180 by doing that change, because it also has processors in there. The management becomes better when you have devices that are designed to do one job instead of multiple things, right? The bad part is, you know, you spend more. But in my case, it's worth it. It's working quite well. I have, I'm not proud to say it, but I have over 30 things connected on my network between, you know, lights and, you know, devices. So I need to be able to run this in my house. I need a good router. It
It's
used,
an investment.
yeah. And also I don't go out, so there you go. I spend my money on these things. Anyway, so yeah, combo device performs the two things: the router and the modem part of it, right? But you could have a switch connected to a router as well to create additional ports. We'll get to that. Another example, you have 3 LANs. Let's say you have a network that's for work, a network that's for guests. So A and B, you would have a specific set of preferences, I guess, or settings for your network that would be different for you than for the guests. It's like having different bands. I don't know if you guys are familiar with, you know, the 2.4 or the 5 gigahertz on your routers, right? You can have a guest one, or you can have one that's specifically for, I don't know, for work, or one for your IoT devices, you know, like the Roomba, the lights, whatever. You can do all sorts of fun stuff with that by separating them in different networks. But they all eventually go and join in a router, and then they all connect to the net. I've never been a fan of these. MAN, WAN, PAN. For me, it's basically all LAN, right? But there are distinctions. They're usually geographical. So Metropolitan, let's say MDC has 8 campuses. All of them are connected via MAN, Metropolitan Area Network. MDC has some sort of link with Louisiana State University. That would become WAN, or Wide Area Network. Excuse me. Because of the geographic location. Regularly, a LAN is a small area, but it could be a building, right? So West Campus would be a LAN. And then PAN would be you connecting your phone to the computer. That's PAN. In the end, who cares? This is all a network, right? It's just definitions that they decided they're important to have. An example of one, right? San Francisco to Philadelphia. There's distance is quite large, so that will be a one. All right. Who wants to be the brave one that explains the OSI model? Because here I'm joking for whatever reason. So the book does a really nice analogy between a network and how it communicates and the postal office. So
What do you want to
what-
know? The layers?
right, the layers of it. So generally,
Oh,
back when we sent letters, right, through the mail, not all that spam that we get. At least I get a lot of spam over the snail mail. You would write your letter. That's your data. Then you would put it in an envelope, put your address in one corner, put the address of whoever is going to be the recipient in the center, and put your stamps, right? That you would deposit in the mailbox, be it yours or one of the, the ones around the city. A car would come and pick it up, take it to a sorting center or a post office like here, and then that will be taken through the road system, the traffic, all that stuff, taken through all over until they reach the destination. Let's say the zip code you're in, right? Then it will go to another sorting center where they'll, here they have these little cars. It really should be the big trucks here, going here, all those huge, freight trucks. And then from here to you, or from you to the post office, would be these little ones. But okay, that's just being nitpicky. So the trucks take it to another sorting center in another location, which then says, okay, you, number one, you're going to take these letters and packages and so forth to this zip code. This is your area, so you go deliver those, and you go and you go and you go. The fact that you have a letter with an address from you and an address where it goes, and that you're using this system of trucks and warehouses and sorting centers and so forth, is a good, it's a similar way of explaining how a network works. So you have a browser, which is working in an operating system. Whenever you open a browser and you send email, it goes through the operating system, your hardware, right, through the different layers and so forth, and then uses the cabling that's, let's say, on the internet in your house, or wirelessly, depending how it's connected, and then eventually reaches another computer where it goes in the opposite direction, right? It goes from the top layer down all the layers, and then through a system, and then back from the bottom layer all the way to the top layer to reach you. Doesn't take too long to do so. So you have to know the names. And what was it again? Jesus, I know someone had it. All people seem, Ike, right? All people seem to need data processing. Thank you. So you start from here. All people seem to need data processing. Even though physical is the first layer, you start from 7, 6, 5, 4, 3, 2, 1, like that. And this is not the best diagram I've found, so you can find others in here under chapter 1, additional resources, that seem to explain, in my opinion, a little better what's happening on each one of them. Anyway, so these you need to know. You need to know where it starts and what happens on each one. Let's go, I guess. So 7, 6, and 5, as you can see them here in green, are kind of a mixed match of them, so it's hard to figure out what's going on where. But the application level, as it says here, describes the interface between two applications on separate computers. You'll see this everywhere. Protocol, 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 right? There's application layer protocols that fall into two categories: those that give services to a user and those that are utility programs. In any case, what's important to learn here is the word payload. And the picture all the way at the end of this makes it easier to understand. So payload is basically the data that you're sending through the network, right? Let me find the... When you reach this one here, the summary, it will make more sense. But for now, let's go on there. Layer 6, called the presentation layer, is where these things happen: reformatting, compressing, encryption of data. So yeah, moving on. Layer 5, you have synchronization and all that stuff. So we'll get to this. Level 4, transport layer. This is where it gets more interesting. 5, 6, 7, and 5, 6, 7 are not as, I guess, interesting for networking. Transport layer, as the name says, it's responsible for the transportation of the payloads, right? The data that is in the previous levels or layers. You might have seen TCP or UDP somewhere. Can anyone give me an example of where you use this or where you use this one? So transmission control protocol. The idea is that TCP says, okay, we're going to send data, but we're going to make sure that the other end, there's someone to receive it. And if there's no one on that other end, then we're not going to send the data.
Like a fax?
I'm sorry?
Like a fax?
A fax? Yes. A fax won't go until there is someone to receive the fax, right? Who sends faxes nowadays? I mean, I sent paperwork. Apparently, the government still uses faxes. Emails usually do that too, right? If you're sending an email and it can't reach the other place, it won't send it. You will see an error message on your email account. Now, user or UDP, where would you see this?
Wouldn't the Zoom call right now be using UDP?
I guess, yeah. Because it doesn't matter. Doesn't matter who connects to, it's still going, right? So if you have a town hall meeting and you use Zoom and it's like a webinar or something, yeah. What UDP does, it's broadcasting, no matter if it reaches someone or not. So if you connect to it or if you receive it, that's on you. So yeah, so a channel broadcasting a digital signal would use UDP because they're not connecting. They're not making sure that they have a connection before they do, the sending of the data. Cool. Just have a bug here. Oh snap! What time does this class end? I hate how 7:20. I think. Okay. Layer 4, still layer 4. Protocols add their own control information in an area at the beginning of the payload called header. So they're basically saying, let's go through this. You need to know what a header is, you need to know payload, you need to know what the process of encapsulating data means. You need to know that if it's UDP, the name of the thing, the payload and the header is called a datagram. And if it's TCP, what was it called? Segment. It's called a segment. Sorry. Network layer. Let me get to this diagram again. All right. So to put things in perspective so that we don't run out of time. This is the worst part of this class. It's never enough time. You always start with an application. Let's say a browser. You're sending an email through a browser. You connect to the internet, right? You're connected always to the internet. And you go to Gmail. That Gmail will send that email all the way through the layers, all the way down here. And as it goes down, 7, 6, and 5 is just called payload. This is the data. This is the content of that email. When it goes to 4, it will add a header and it will encapsulate this, and it will be either a segment or a datagram, depending on if it's TCP or UDP. When it reaches network, it will add another header to this HP, header and packet and payload, and it will call it a packet. Once it reaches number 2, layer 2, it will add a header and a trailer, and all of this together will be called a frame. Now, why is this happening? Can you tell me why is this payload, the data that you're sending, why are pieces being added here?
As it transports through each router or server, it's losing a piece of knowing where to go to.
It adding, not the. Well,
Would
it will lose it on the other end, saying you know where you go, but you're adding pieces here. See?
Would it be as a system for the other server to check that the information that it is receiving is correct or that it's going to the right place?
Yes. So
Isn't it like a security kind of reasons? It goes from HP down to the HHPT is like the most secure.
no, this is just to make sure it reaches the right place. The
Mhm.
security part is
Oh, this is the last one is the most secure, right? The HH.
no. So you have a letter,
Mhm.
right? That's your payload. Then here you're gonna insert it into an envelope, right? Then you have your segment or datagram. Then here you're gonna say, okay, I'm gonna send it to this person. You know, you write it on that envelope, you send it to this person, and I'm gonna put my address as well, so
Like
that they know where it's coming from.
Get the IP address in that case.
Right. So, and then here it's saying, okay, well, my zip code is there, and you know the whole system that's gonna transport all of this stuff puts their own little pieces of data there so that they know where to send it, like the barcode that you see on your letters that the post office puts, right? When it to sort all your mail. Similarly, yes, you have pieces of data that are added to whatever you're sending, and sadly they're called different things depending on what layer they're in. So you'll need to learn payload, segment, datagram, packet, frame. And each one of these pieces that they're adding is so that we know where it's coming from and where it's supposed to go. The physical layer doesn't have any of this. It basically just says, let's just use the hardware and route it. So if you have a browser and you're sending an email, you're saying, okay, send the email, go through all these steps of adding all these bits and pieces to say, well, yeah, my IP address, to what IP address I'm expecting to send it, through what type of hardware it's going, so that we know, where. Let's say you send a letter to someone and that someone doesn't live there. You get a return to sender on it, and then the post office sends it back to you. The only way for the post office to be able to send it back to you is because you put your address there, right? All these pieces are there. Who you're sending it to, what you're sending, the payload, and where it's coming from, your particular, let's say, IP address. So this all goes. Yes? Jonas? This all goes through the wires and such that you have that make the big internet as we know it. It might pass through switches, which some switches, have 2 layers. Some switches have 3 layers. This one has 2. Oh, okay. It's going to this particular place. Okay. Send it to a router that has 3. This one has 3 layers. And it says, okay, I'm going to read where it's coming from, where it's going, so that I can route it to the specific place it needs to go. And it's basically, there's a lot of switches and routers in between, eventually leading to the web server. You sent an email, you use the application, you use your own servers there, and eventually reaches from Google to Yahoo. And then this computer on this other end, Jonas's computer, starts decoding all these pieces and taking pieces out until it reaches the payload, which is the message you intended to take, to send. All, of course, happens rather quickly, but what it basically does is going in the inverse. You start 7, 6, 5, 4, 3, 2, 1, and then once it reaches its destination, it starts taking the pieces out to make sure it reaches the intended recipient, intended address.
Who selects the administrator is the one that selects the amount of layers, like for the switch and the router? Or is that just
No,
is?
you have
Is that how it is all the time? Like you get 2 layers for a switch and 3 layers for a router?
no, the devices basically will have that, but you can have some switches that have some sort of router capabilities, like have the network layer as well there.
Mhm.
So they're more advanced and you don't need to have a router per se to do that.
Okay, so that answers my question. So switch only always just has a physical layer and a data link layer.
I mean, we'll have, yes, always minimum that.
Okay.
Physical is just the hardware, right? And,
Yes.
and then the data link is part of the whatever it does to say, okay, where do you need to go? A router determines what network it's supposed to go to, because the router is what connects 2 networks together, right? So it goes from one network to the router. This router would say, okay, where on the internet do we need to go? Send it there until it reaches its destination. It might go through thousands of them, or just a few of them throughout the journey, but essentially is that. But yeah, there's different kinds. It really isn't about don't worry too much about how many layers it goes. Just figure out where it comes from and where it's going from. And it goes from 7 to 1, and then once it reaches its destination, it goes from 1 to 7, right? The rest is safety stuff. This is my favorite diagram from this chapter, because sadly, I'm not gonna go through all of this, but read this part. Yes, that's good enough, William. It changes virtually nothing, Here it talks about MAC addresses, which we already talked about. Physical could be any of these things. If you read the book, if you have a link, by all means. If you read the book, it explains exactly what all of these things are. But fiber optic cabling is light transmitted through a cable. Voltage or in a copper wire could be a twisted pair like Ethernet or coaxial, for example, or in wavelengths through the air could be a wireless signal like radio.
Professor, is it possible to hack an email in the air? Wirelessly?
Nothing is impossible.
Just grab the packet, right? The packet, and you can.
Yeah, you can intercept things. I mean, think about this. If let me close this.